Okay, in this video we are going to talk about how to find the derivatives of exponential functions of all sorts. Exponential functions, there's a very famous one that everyone really thinks of, and that is f of x equals e to the x. So I think most people think like that's the exponential function. And the derivative of e to the x is also really famous because it is its own derivative. E to the x is a function that is its own derivative. So f prime of x would be e to the x. Really easy to remember that one. The less famous varieties are not really any less important. The less famous ones, instead of using a base of e, they just use kind of like a generic base. So I'm going to say a to the x. There's a bunch of restrictions on that. Like technically a cannot be 1, a cannot be negative. But you know what? You're not going to really run into that in calculus, so you don't really need to worry about it. So a to the x, where a is some constant. So these are not polynomials, they're not power functions, not x to the a. It's a real number raised to the x power. And then f prime of x for these is a to the x. So far it's basically the same as e to the x, but now times the natural log of a. So I didn't write it in this video, but the e to the x definition works the exact same way. It's the derivative of e to the x is e to the x times the natural log of e. It's just that the natural log of e is 1, so we don't write anything there. But when it's a to the x, it's going to be, the derivative will be a to the x times the natural log of a. And you cannot forget that natural log of a. That's actually going to be really important going forward when you try to reverse the process. So instead of taking a derivative, you're going to have the derivative and try to go back to the original function. You need to remember that there should be a natural log of a there, or you're going to forget something. And then both of these could definitely use the chain rule. So now what I'm going to do is I'm going to do 4 examples just so you get an idea of what's going on. And it's really just about like not forgetting. So don't forget that natural log of a. So if my first example is f of x is e to the 5x. All right, so this is going to be a chain rule problem. The derivative of e to the anything is going to be e to that thing. So that's what I always start with, like e to the u, the derivative is e to the u times du dx. So it's going to be e to the blah, the derivative is e to the blah, times the derivative of blah, so times the derivative of 5x, so times 5. And I think typically you'd like rewrite this as 5e to the 5x. Not really the point of the video, but I wrote it anyway. All right, let's look at another example. So we have f of x is 5 to the x squared. So this is an exponential function. The base is not e, so I want to remember I need to multiply by the natural log of a. And then it's a chain rule problem. So let's see if we can do it. So f prime of x is going to be, so the derivative of any exponential function is just the original exponent. So it's 5 to the blah. The derivative of that is going to be 5 to the blah times the natural log of 5. And then times, so all of that is just from the derivative of 5 to the blah. Now you have to chain rule this thing. The derivative of x squared is 2x, so times 2x. And I don't know, you'd probably rewrite this as like 2 natural log of 5 times x times 5 to the x squared. I didn't do that because, I don't know, it wasn't the point of the video. Another example. F of x is cosine of e to the radical x. So there's a lot of chain rule here. And it's like the inner function is an exponential. So first thing I need to do is find the derivative of cosine of something. So the derivative of cosine of something is the negative sign of that thing. So negative sign of that thing times the derivative of that thing. So that thing, that inner function is e to the radical x. So now I need to think, what is the derivative of e to the radical x? Well, the derivative of e to the anything is e to that thing, and then times the derivative of that thing. That thing is radical x. So what's the derivative of radical x? I always think of it as x to the 1/2, and then just kind of power rule it. 1/2 x to the negative 1/2. This I think you would clean up because of that negative exponent and the 1/2. So I rewrote it as negative e to the radical x sine of e to the radical x, and then all over 2 root x. And I left it like that. All right, I got one more example, so let's take a look. So it's 3 to the tangent of 5x. All right, so it's 3 to the something. The derivative of 3 to the something is going to be 3 to the thing times the natural log of 3. So that's where I start out. 3 to the thing times the natural log of 3. And once I have that, now I'm like, well, then I need to chain rule, right? So this is the part where the chain rule comes in. We haven't chain ruled yet. It was just 3 to the 10 of 5x. The derivative of that's going to be 3 to the 10 of 5x times the natural log of 3 times the derivative of the tangent of something. Derivative of tangent of something is secant squared of that thing times the derivative of that thing. That thing is 5x, so we'll multiply by 5. Then I rewrote this one because I feel like you would never leave the natural log of 3 in the middle. Although I did it on example number 2. I don't know, whatever. I rewrote it. So f prime of x is 5 natural log of 3. I couldn't really decide what order to put these two functions in. And so I put them in this order. I think either order would have been fine. All right, so that's derivatives of exponentials. You've got your famous derivatives where the base is e, and that's most of them are going to be that. But you got to really remember when the base is not e, you need to multiply by the natural log of the base. Otherwise, you're missing a factor in your derivative. All right, so I hope this was helpful, and good luck.